I presume that you already start to watch the tutorial videos for this week. Starting from this week, we're getting to something that's become sophisticated. Especially you have to use arrays and loops, a combination of both. And for your lab test 2, after the reading week, I'll give you preparation guide early this week so you can start preparing for your lab test 2. But guys, even this level is not tolerant. It's not tolerable. Okay, thanks. So now let's talk about more examples about arrays and loops. So I think having an example to really explain to you every detail about how you can manipulate the array is really the best way. But let's go over one by one. The first example, okay, over here. Okay, so now this example over here, we talk about 3 different approaches in your tutorial videos. I'm going to talk about another one, which I mentioned briefly in a Moodle announcement over the weekend, but I'll go over it in detail together with you. And using this example, I'm going to review all the basics about array, everything you should know about the array. And of course, we're going to learn about more complicated example towards the end of today's lecture. Okay, let's do this one. And this sequence must be quite familiar to you. It's basically an arithmetic sequence. How do we tell? Well, you can see that the first term for the arithmetic sequence here is 7. And then between every pair of elements consecutively, we got common difference, simply just 3, right? Until the last term, which is 34. Okay, that's kind of the pattern we know about. So later on, whenever you want to really construct an array and try to fill in the contents, you may just want to first convince yourself whether there's a pattern or not. In this case, there is indeed a pattern. Okay? For your lab number 3 for this week, this might be relevant, right? Because we talk about geometric sequence and also arithmetic sequence. They follow similar pattern. It's just that the formula is a little bit different, but the idea is really the same. Okay? Let's try to learn from this example here. I do have some Java code over here, which I would like to go over with you line by line. Okay? And also, I got a table over here to trace the code together with you. It's really important technique I want you to pick up. Okay? So now let's go over line by line. Our goal is to initially construct an array that looks just like IA. That's what we would like to achieve. Okay? Let's see how we can do that. Now, number 1, we want to know how large the array is that we want to create. In this case, we know that starting from the minimum index 0 until the last index 9, we know that there are 10 elements in the array, right? The size should be 10. This is why in the first line over here, again, let's review the syntax. You have to declare what's the type for every element in the array. And then you use the empty pair of square brackets over here to tell that it's an array. Every element in the array has the type integer, in this case. Of course, you can change int to character, boolean, string, as we'll see later in the lecture. Okay? And then, as usual, we have to declare the name of the array over here. I just call it seq, standing for sequence. And then it is going to be assigned to something on the right-hand side. On the right-hand side, we have to use a new keyword in Java. That's something you have to do syntactically. Otherwise, your code wouldn't compile. And then we simply say new, create to me a new array. And then what about for the new array? Every element in the array is going to be an integer. And then the size of the array should be 10. And over here, this particular size expression in here, I'm just giving you a concrete number over here, just 10. But in your lab exercises, it might depend on what the user wants to enter. Okay? So it doesn't have to be just a specific number. It can be even a variable. Okay, so what this line would do is, let's just draw it very quickly. Conceptually, that's how you can think about it. So we have an array called sequence, seq. So sequence is pointing to an array that looks like this. Okay? We know that it's going to be of size 10. Always the first index should be first index should always be 0. 0, 1, 2, and all the way to 8 and 9. Let me just put them just as illustration. Okay? Of course, the array size can be arbitrarily large. It can be 1,000 or it can be even a million. Doesn't really matter. Okay? So now let's see how we can analyze the rest of the code. The idea is as follows. We want to start with knowing that the first term is simply just 7. And then from then on, what we want to do is if I want to know what should be the item for this particular index, because I know that it's an arithmetic sequence, that should be exactly the previous term plus 3. Similarly, if I'm currently here at index 4, I want to know what the number it is. In this case, it's 19. How do I figure out? I simply look up what's the previous number at index whatever I is minus 1. Go there and then plus 3. That's kind of the insight we're building. And we're doing this exactly in the loop. Okay? Let's see how we can trace the code. So now we haven't got into the loop just yet. Let's do some preparation. If you look at this line over here, let me use maybe green. So this line over here, we say sequence, which is an array at index 0, is on the left-hand side of the assignments, which means we want to change that particular slot of the array. So what value do we want to change that into? Look at the right-hand side. We want to change that to 7. Okay, so now sequence is this particular array. I want to change index 0, which is over here, change that to 7. So I'm just modify that to 7. And by the way, one small detail which you already pick up in the tutorial. Initially, when you first create the array, like over here, all the slots are going to store default values for that particular data type. In the case of integer, it's just going to be 0. Okay, we'll talk about other default values a little bit later in the course. So initially, you can think about everything in the array is just going to be 0 right after this line over here. Okay, so now, again, let's look at the green one over here. We say sequence at position 0 should be assigned to 7. Go to position 0, reassign that to 7. Okay? Any questions so far? We haven't got into any loop just yet, but we will do that in just a moment. I'll show you a couple of iterations, and you will see the pattern, and then we are done with this example. So what I would like to do is, let me show you the code structure first, and then we'll trace the code together. If you look at the code structure over here, first of all, you can see what is the initialization. Initialization is we declare some loop counter over here, simply I. And initially, it's simply just 1. Rather than 0, because we have already taken care of index 0 in the previous line. So we can start with index 1. Okay, I'll show you what that really means. And then the state condition over here is really standard. We simply say we're going to stay in the loop as long as I is strictly less than sequence.length. Notice that sequence.length, in this case, what is that? Think about it. If you think about sequence.length, in this case, because the size of the array is simply 10, sequence.length will just be 10. If you say I is strictly less than 10, that means the maximum value can get into will be just 9. So that makes sense for this particular example. A very common mistake is if you simply say less than or equal to sequence.length, that will simply just be wrong. You will run into some array index out of bound exception. Okay? Good. So far, so good. And then finally, we want to say at the end of each iteration, we're going to increment the loop counter I by 1, I++. Okay, very standard loop. Now, what's really interesting is the body of the loop. It's only one line, but it's kind of somehow more complicated than what you have seen so far. Okay, let's spend some time on that line. What I have over here, which I'm going to use pink to highlight, I say sequence I and on the left-hand side of the assignments. So that means whatever I value is, I'm going to modify that particular position in the array. I could be 1 to begin with, all the way to the last index, which is 9. Okay, that's basically what I'm trying to do. So I can be 1, I can be 2, I can be 3, all the way to I can be 9 eventually. Okay, that's what's going to happen, but let me undo that. And then let's look at the right-hand side of the assignments. The right-hand side of the assignments is the sequence at index I-1. That's the interesting bit. So remember what I said before, if I want to figure out what this value is, I simply go to the previous value and plus 3. How do I go to the previous value? The previous value is simply stored at the index that's -1, right? You can see if currently I want to go for this element here, the index is simply 1. What's the previous one? The previous one will just be of index 0. Okay, and then want to look up what the value is. That's kind of the idea. So I simply say sequence, let me just make a comments for you. So this simply means the previous, what you can think about is the left neighbor. The left neighbor of the previous the current element. And then we're going to plus 3 to it. Okay, whatever the previous value is, plus 3 to it, you will get the current term. So now this, you can see this fragment of code, only about 5 lines of code, but quite many things you want to understand, especially when you trace the loop. Let's do it together. Again, so this is what I will recommend when you try to trace the code. You don't necessarily have to do a big table. As long as you can get to the point that you really understand the pattern of your loop, you can stop. Okay, that's exactly what I'm going to do. I'm not going to show you all the 10 iterations. I'll just show you a few so that you get an idea. Let's try the following. Okay, so now we are already done that at index 0, we are storing 7, okay, right after this line. Let's try to initialize the loop. Okay, first line we want to see integer I is initialized to be 1. That means I's value is just going to be 1, right? And then we're going to check the state condition for the loop over here, right? We're going to check to see I strictly less than sequence.length. And by the way, we know that sequence.length in this case is simply just 10. So that means we're evaluating 1 less than 10. In this case, it's simply going to be true. That means we go into the loop and do it the very first iteration for the first time. Okay? And we only do I++ at the end of the iteration. We don't do it just yet. Okay? Again, you want to really be very clear about what's going to be the steps for executing a loop. Okay, for your convenience, it's because we know that the state condition is simply just true. That means we're going to go into the loop. If you go inside the loop body over here, we're going to execute this particular assignments over here. Okay, what would this be? What would this look like? If I just write it over here, for this, for the very first iteration, it will just boil down into sequence at position. The current value for I is simply just 1. So that will be 1. Is assigned to, what is I minus 1 in this case? 0. Okay, that's the index we want to look into. So that would be sequence at position 0 and plus 3. Okay, so now think about this is exactly what you have to execute for the very first iteration. Because in the very first iteration, I's value is simply just 1. So what would that do? It would simply say whatever the value is at position 0 plus 3, change that into the new value into position 1. Okay, what that would do is we want to change for this particular position over here. Okay, and now we want to look at what's I minus 1 position. And the value over there is simply 7 as we did before the loop. So that means sequence at I minus 1 is simply 7. And then we simply do this calculation. Sequence 0, which is 7, plus 3 will give us 10. So that means we update this value here to be 10. Okay, that's after the very first iteration. Let me do one more iteration to show you, one more. The pattern goes like this. I want to fill in the arithmetic sequence from left to right. I filled up the leftmost one before the loop. And then I start a loop from the second one. And then always I want to figure out the current elements by adding the previous one plus the common difference. Okay, that's the pattern. If you want to talk about alternative solution, let's hold it off. Let me just finish this, okay? Let me talk about the second iteration here. So now at the end of the first iteration, I'm going to do I++, okay? So now let me do another color. So I++ is going to be at the first iteration. I++ is simply just going to make it I from 1 to 2. Okay, so now the value for I is simply 2. And we do the same check. So now we're going to check the state condition over here for the second time. Okay, so now that means I now is simply just 2. Strictly less than sequence.length, which doesn't change because we don't grow or shrink the array. 2 less than 10 is still going to give me true. So what does that mean? Go into the loop for the second time. All right? If you go into the loop for the second time, let's be a little bit quicker this time. I still want to evaluate this particular line over here. What would that boil down into? What does it boil down into sequence at position I? In this case, it's simply just 2. It's assigned to sequence at position I minus 1. I minus 1 is the 2 minus 1, which would be just 1, right? Sequence at position 1 plus 3. Okay, that's exactly what's going to be calculated. You can see the pattern of the computation is really the same. It's just that we are playing with the index over here between the iterations. That's really the key for you to pick up for this particular example. And now what would be, in this case, we want to figure out what should be the value for this particular index 2 over here. What we do is go to index 1, and then the value we just filled in the previous iteration is simply just 10. So 10 over here, 10, and 10 plus 3 is going to give us 13. That means we're going to get 13 over here, and so on. Okay, so now that will be the very first 2 iterations to run. Let's now fast forward. Let's say we go on like this. Let's think about what's going to be the very last iteration value for I. What's going to be the last? I will be of what value? The very last one. Think about this. The last value for the iteration is going to make this I less than, strictly less than sequence.length to be true. So I strictly less than sequence.length is simply just 10. What will be the last value of I that's going to make this comparison true? 9, right? So that means go all the way to, please make sure you're comfortable with the pattern for the indices, the loop counter. The last one will be just 9, okay? And now we have 9 less than 10, evaluating that for the last time. And then that's going to be true, okay? And of course, let me talk about the loop body in just a moment. Of course, in the next one, at the end of the iteration, from 9 to 10, now from 10 less than 10, you just get false. That's the time to exit, right? So now what should we do in the very last iteration? Let's think about it. What we will do is, we want to figure out what I minus 1 is, which is 8. That means we want to figure out exactly what this value is. In order to do that, presumably from the very second last iteration, we have already filled in 31. Okay, you can do the exercise by yourself too. So now, how do I figure out the last value to fill in? I simply get the value at the previous position, which is 31, and plus the common difference. That'll give me 34. Okay, so I'll get 34. That's exactly what I will get. So 9 here will be I minus 1, and also the previous one should just be 31. So the pattern will just follow like this for 10 iterations. Okay? Any questions about this particular example here? So quite many things for you to recall. Number 1, you want to know how to declare an array of a particular data type. And number 2, there are two things you want. Let me summarize in one page for you. Okay? When you declare an array, you can say integer array, right? Put a name. That's how you declare. How do you actually create a new array, initialize it? You can say A is assigned to new integer array, and then you put some size over here. I'll put question mark. It can be any integer expression. Now, there are 2 things you want to keep in mind. How you can use a particular slot of an array, and how you can assign to it. Okay? Let me talk about 2 things quickly as a review. Reassignments of a slot. For example, you want to say A at position, for example, 2, is reassigned to 8. That's reassignments. In this case, the array indexing notation simply appear on the left-hand side of the assignment, like how you reassign a variable. Number 2, how do you make use of an array? Accessing the value stored in a slot. How do I do that? So for example, I might say, I want to say system.out.println. I simply want to print out 8 at position 3. In this case, I'm not changing any value stored at a particular slot. I'm just using it. Okay? Of course, the more sophisticated example would be when you say sequence I is assigned to the value for sequence I minus 1 plus 3. So that's why I talk about this example here. Okay, so these are the basics for the array, which I assume you should be reasonably comfortable with after today. Okay? Questions? Are we okay? Yeah. Okay. Very good. So now let's talk about another example. So we'll just keep doing more examples. And this next one. Okay, so this one here, if you look at the slides, basically we just want to talk about something other than an array of strings. Let's talk about an array, something other than an array of integers. Let's do an array of strings very quickly. Okay? I just want to remind you about the notation. Okay? Let's just go over the slide quickly so we can do more complicated example. And this one corresponds to the last video you have to watch for this week. Okay? How to greet people in an array of names. Let's do it quickly so we can talk about spend more time on other examples. So now if you look at this line here, on the left hand side we say an array of string. You can see the difference over here is, if I just go back there, so rather than having an array of integer, I can say an array of string. And then I can say names, and then assign to something over here. Oops, let me try to, thank you. Yeah. Let me just put this guy here. Okay, that's exactly what you just wrote. Basically, the only difference is you can see you can either have integer or you can have string before the array expression. And one thing you want to note, if I declare this array to be of string type, if I say new, then that means accordingly, this type over here must be a string as well. Okay, maybe you noticed that from the tutorial video. Okay, more to say, you can, that's how you create a new string of size 10. And also, you can either use the array initializer notation. You can see inside the curly brackets, every value over there is a string literals, right? That's why every element is a string. And then you can also get the first one. So now, these two lines are also important for you to really remember. If you want to get to the first element in the array, regardless of the type, always go to index 0. Always. If you want to go to the last elements, always you try the following expression. You want to say whatever the array is, in this case names, the length, which is going to give you how long or how large the array is, and then -1. -1 because the array indices always start with 0. Okay, remember also in the tutorial video I tried to explain to you, in the C programming family, the way that you get access to the array is by look up the memory address. So you can look up the details in the tutorial video. Okay, okay, and then the number one common error you might make for array is array index out of bound exception. Okay, easy. Either you give an array index that's strictly less than 0, -1, -2, -3, or you give an array index that's a little bit too large. What can be the most common too large index? Well, the most common error is, let me just emphasize that again. The most common one is, if I try to do the following loop, if I say for integer I is assigned to 0, which will be the first index, and then I say I less than or equal to, let's say the names array, the length, and then I plus, and then I do something over here. So this is very common mistake. What's the mistake over here? Well, this guy over here. You shouldn't include the equality over here, right? So this state condition tells you that I value can get up to and including the length of the array. That's not good. If the length of the array looks like this, okay, 1, 2, 3, 4, 0, 1, 2, 3, and 4. Let's say this is the array, let's say. The length, in this case, will just give you 5. Agree? So now, if I say I is less than or equal to this particular array, let's say 5, that means I can get up to and including 5. And now, inside the iteration, if I say AI, in this case, I'll simply get A at position 5. And there's simply no 5 over here. So array index out of bound. So that's a very common mistake. But when you get more and more used to it, hopefully that will be minimized. Okay, let's talk about more examples. Let me just tell you one thing more. That's also very basic. Remember we spoke about how you can translate while loop to for loop. Okay, this one I can just put it here. So now, we have seen this already many times. So you can, if you want to use a for loop, you simply initialize the loop counter I, and then I strictly less than and names that length I plus plus. That's easy. And remember we talked about how you can translate from for loop into while loop and vice versa, right? This one here, you can also feel free to use a while loop. Actually, in the tutorial videos, I also show you how to use a while loop to iterate through the array. So now, in this case, I simply move the loop counter declaration over here outside the while loop, right? Initialize the loop counter to be 0. As long as I is strictly less than names that length, I'll keep going, right? And then make sure you put I plus plus at the end of the iteration, right? That's why it's very easy to see. So these two loops are completely equivalent. Especially, pay attention to the state condition. You can see the state condition here, I strictly less than names that length. And also here, I strictly less than names that length. Okay, important. Okay. Let's now do a series of problems all together, okay, just to strengthen your understanding, and we'll do more on Wednesday. Number one, let's look at the problem first, and then we'll do it together. Given an array of numbers, let's say simply integers. So we have an integer array. We want to know what's the average out of all the numbers in the array. For example, if you have an array, let's say 1, 2, 6, and 8, I want to figure out exactly what the the sum of the numbers are, and then to divide them by exactly how many numbers I'm calculating, right? In this case, it would just be 4.25. You can verify the math by yourself. It's a very basic problem to solve, okay? The good thing is, if you try to run this program from the user can enter as many numbers as they like. So that's actually a very powerful thing to do. Okay? So now, how do we write this program over here? Okay? It's a basic one, so I will show you the solution right away. And then we'll go over some details together. Okay? The solution looks like this. Okay? Let's, for now, assume we have an array over here. We have numbers here. Okay, and then we got simply 1, 2, 6, and 8. So numbers that length would just be 4. Okay, so now let's look at the lines of code. Not too many lines of code. What we are doing, let me just highlight to you the critical things you want to pay attention to. We have loop counter I over here, initially 0, strictly less than the length of the array. Okay, I++, very standard way. Whenever you got this pattern here, you want to go over the element in the array one by one. And then we got something over here as the body of the loop. What we are doing is we want to somehow calculate what's the total sum of all the numbers in the array. We want to really accumulate the value for the sum after each iteration. So maybe for the very first iteration, the sum will just be 1. And for the second, after the second iteration, it will be 1 plus 2, which is 3. After the third iteration, it's going to be 1 plus 2 plus 6, which will be 9, etc. Okay? But how do we do that? One way to do it, which is very common, is to have an auxiliary variable over here, or helper variable. That's outside the loop. I initialize the sum to be 0 over here, and then between every iteration, I'm simply just going to increment the sum. You can see plus equal, right? So this line over here is equivalent to sum is assigned to sum plus the numbers at position I. Okay, that's exactly equivalent to that. Okay, we talk about this shorthand notation back in elementary programming lecture. Okay, so that's what we're doing. So now when we exit from the loop into this line, we know that sum must have accumulated all the values in the array. And then what we do is we simply want to divide the sum, which is an integer, by the number of elements in the array, which is also another integer. Remember we said before, if you do integer divided by integer, it will only give you the quotients. It wouldn't give you the precise result. How can you resolve that? Cast. Okay? One way to do the cast is by using the double. Okay? That's, again, a review from the previous lecture. After that, we can simply print out the average. Okay? That's the structure for the loop. Let's now run one example together. Okay? Let's say we have test case number 1. Okay? I simply consider this particular array. Let's say the numbers is simply consisting of 1, 2, 6, and 8. Okay? Let's say we have that. Okay? Only 4 numbers. Now, let's anticipate how many iterations do we expect to run? Since we got 4 numbers, there should be exactly 4 iterations, right? So out of the 4 iterations, we're going to accumulate the sum, one value after another. Let's see exactly how we can do it, okay? Again, let me draw a little bit table over here to help you, okay, to understand. Specifically, let's talk about the value for I, the loop counter, and also I less than numbers.length, the state condition. As long as it is true, I'm going to stay in the loop. And also, I have another one here. What will be the value for the sum? Okay? That's what we want to do. So now, let's have a look. For the very first iteration, I is going to be initialized to be 0, so I put 0 over here. 0 strictly less than numbers.length. In this case, of course, is simply just 4. Okay, let me write it down. So that means we got 0 less than 4, which would be just true. That means I want to execute the body of the loop for the very first time. Okay? So now, you know what? Let me put the sum in another place. What about the sum? Let me put the sum over here. It's a standalone box over here. This is the sum. Oh, you may not be able to see it, right? Let me just put it here. Let me put the sum over here. Initially, sum is simply just going to be 0. Let's see what's going to happen after the first iteration. The first iteration is simply going to execute this particular line where I is simply just going to be 0. That means we're executing sum is assigned to sum plus the numbers at position 0. What's numbers at position 0? Well, simply just 1 over here. And 1 plus whatever sum is, which is 0, is going to be just 1. The first iteration is easy. Okay? That's after the first iteration. And what do we do at the end of the first iteration? We're gonna increment I by 1. Let's try that. If you try to increment that by 1, that'll be from 0 to 1. Okay? So now we have to check the state condition over here for the second time. So what do we have? 1 less than 4 in this case is still going to be true. Okay, the same. So now, and then that means we're going to execute the body of the loop for the second time. So now that means we're simply going to execute sum is assigned to sum plus numbers at position now used to be 0 in the previous iteration, but i's value changes. So now that means it's simply just going to be 1. What's numbers at position 1? It's simply just 2 over here. That means it's going to be 1 plus 2. It's going to be 3. Okay, you can see we keep accumulating the value for the sum between iterations. That's really the main thing for you to notice. Okay? Okay, let me just go without going too much further. So now, what about after the third iteration? The third iteration is simply just going to accumulate the third elements in the array into the sum. That means 3 plus 6 is going to be 9. And the last iteration is going to be 8 plus 9, which is going to be 17. Okay, that's exactly what's going to happen between the iterations. Okay, what you will get is 17 will be the value over here. So that means for the sum, you will simply get 17 divided by however many elements you have in the array. In this case, simply just 4. And then you get your result. Okay, that's about it. Let me say one more thing. The code over here may not be very robust. Robust in the sense that if you give some other input value, your program may crash. Okay? Can you anticipate what can crash in this case? Let me give you a little bit of hints over here. Whenever you talk about crashing, one way to crash your program, even before we talk about array, is when you have division by 0. Is it possible to have division by 0 in our case? We do have a division over here. It's division by numbers.length, right? Well, let's talk about another test case. Let's say we talk about another numbers over here. We simply put just empty curly brackets. As we talk about in the tutorial video, if you simply got this, that simply means empty array. What does empty array mean? It simply means an array that contains no elements inside. And if you got this one here, as soon as you create this, if you say numbers.length, the length is simply just going to give you 0. Okay, that's a very special case you want to be careful about. So now, let's say if we simply try to run our program over here with this particular case, what's going to happen, really? You want to, let me just see if I got, okay, that's it. Okay. Basically, what was going to happen is, when you reach this particular stage over here, exit from the loop. Let me say one more thing. Let's talk about this particular test case. Okay, we got to talk about test case number 2 when numbers.length is simply just 0. Okay, so now let's say we still do this particular line over here. So the sum will still be initialized to be 0. Okay, after this line. Okay, as before. So now tell me something. What's going to happen when we try to evaluate the header of the loop? Are we even go into the loop body for the first time? Okay, if you think that's no, that's good. It's a good sign. But you want to know exactly why. Okay, it's a subtlety over here. I want to make sure you understand. Okay, so now think about what we're doing here. Okay, let me just use some color here. Let's use maybe green over here. Green is not good. What about orange? It's fine. Okay, now let's say currently we still try to initialize I to be 0. Okay, I is simply just 0 as before. And now when we try to evaluate this particular state condition here, what's the value for I initially? I is simply just 0. Less than, since we talk about this particular array that is empty, numbers of length will also be 0. 0 less than 0 will give you false. That means your state condition is false right away. That means you don't even go into the loop body for the very first time. Okay? Could you please put the headset down? Thank you. So now, if you have this, the state condition over here is simply just 0 to begin with. That means don't even go to the loop body for the first time. So that means we're going to bypass this particular loop body here, and then we simply go to the average calculation. In this case, numbers.length will simply just be 0. So you got division by 0. Okay? So the lesson to learn from this particular test case is you will get division by 0 exception. How do we fix it? Well, let's say if you're doing some console application for the lab, all you have to do is, if you want to calculate the average for a particular array, you better make sure the array size is strictly larger than 0. It cannot be empty. Okay? Questions? So I would say the second discussion over there is more valuable because you want to know if there's under any circumstance can your program crash. That's actually very important to realize. All right, so now let's go on to the next one. Okay, that's about the average calculation. Second one, given an array of numbers again, how can you print the contents backwards? Okay, it's an interesting problem to solve. Let's say this. If I have an array 1, 2, 3, 4, I give you that. At index 0 is 1. At index 0 it is 1. At index 1 is 2. At index 2 is 3, etc. But when you print it out, I don't want you to print out from left to right. I want you to print from right to left. How do we do that? And the reason I'm showing you this problem itself is actually, well, quite kind of like a basic problem here. The interesting bit I want to show you is how you can play with the loop counters to make this happen. That's where the problem is interesting. Okay, so let's try to solve that. I'm going to show you 2 possible solutions. If you come up with a third one, that'd be great. You can just make sure if that works or not. Okay, we got 2 possible solutions. I covered the solution already. I also give you a little bit hints. Okay, let's talk about solution number 1. Again, let's understand what the problem is. If I give you this particular, let's say numbers array is simply pointing to an array of size 4. I got 1, 2, 3, and 4. I got 4 numbers over there. But now when I try to execute the fragment of code in the console, what I want to see is not 1, 2, 3, 4. I want to see 4, 3, 2, and 1 in the reverse order. Okay? That's what I want to do. Let's talk about 2 possible solutions. For each solution, I fix a particular part of the code to constrain you. In some way, I'm giving you some hints about how you should think about it. Number 1 is easy. Okay? Number 1 over here, I simply say the hints is I want to have a for loop over here, and then whenever I try to print out in the body of the loop, I simply use numbers at position I. Okay, that's a constraint for you. So, what does that really mean? In the very first iteration, which index in the array do I want to get into? The last index, right? Let's think about it. Okay, let me just write it down. So now, if I go for this particular solution over here, that means in the very first iteration, I want to print out numbers at position 3. And by the way, this is really the same as numbers at position numbers.length minus 1, right? The last one, okay? Just a reminder. And then for the second iteration, I want to print out numbers at position 2, and then numbers at position 1, and then numbers at position 0. That's what I want to have, right? So now I want to really change the loop header in such a way that the value for I is going to give me 3, followed by 2, followed by 1, followed by 0. Okay? So now how do I do that? Well, basically, if you recall what we said in the tutorial video, the initial value for the loop counter can be any value. It can be 0, can be 1, can be negative value, any value. And the way you update the loop counter can be anything. It can be plus plus, or it can be even minus minus. Okay? That's the key, right? So now, let me suggest to you one almost perfect solution, almost. What if I simply say this? For this particular array, I can say for integer I is assigned to 3. Now, let me leave the state condition over here a little bit, question mark for you. And then I can say I minus minus. Okay, and then I can say print line, as before, print line, numbers at position I. Okay, so now you can see the initial value is simply 3, and then every time at the end of the loop, I'm going to decrement the value for I. So 3, 2, 1, 0. So now the problem is, how should I specify the state condition over here, right? As long as what is true, should I stay in the loop? I cannot say I is strictly less than numbers.length anymore. That's not going to help, right? Because I decrement the value of the I. Okay, let me suggest something for you over here. What you can try is, you can say I larger than or equal to 0. So what does that mean? That means I'm going to start with the I value with 3, and then I'm going to decrement I from 3 to 2, 2 to 1, 1 to 0. I don't want to go any further from 0 to minus 1. That's something I want to avoid. That is why in the state condition over here, I say, as long as I is larger than or equal to 0, I'm going to stay in the loop. As soon as I is strictly less than 0, exit. Right? That's kind of the logic. Okay, that's the almost perfect solution. However, I'm not very happy with this particular part over here. I highlighted for you. I'm not very exactly happy with I is initialized to be 3 because it's too specific to this particular example where the size of the array is simply just 4. What if the size of the array is simply 1000? I got to change the initial value for I as well, right, to 999. Can we rewrite this particular initialization part to be more general? Which means it will apply simply to any array I give to you. Anybody? Yes. Yes, exactly. That's exactly right. Because we know that the 3 over here simply means the last index in the array. So why don't we simply do the following? Right here, numbers at length minus 1. Right? Exactly what you suggested. That's good. All right? And then we still have this state condition here, and then we got an update over here. Okay? The first one is actually quite straightforward. It's not too bad. It's a warm-up for the second one. Okay? The second one is more challenging. Okay? Again, the beauty about the loop is we're trying to patternize something that can be repeated. But the problem for you to solve is really identify the patterns. And second one, illustrate that. Okay? Let's figure out the second one. The second one over here, let's see. Let me give you a little bit hints. For the first one, I constrain the header, for the first one, I constrain the body of the loop for you. That's what I constrain, fixed. But now, for the second version, I want to fix the header of the loop. I indeed want to start with I being 0, the leftmost index, even though I want to print out the rightmost index first, even though. And then I use the very standard loop header over here, I strictly less than main.length, and also I++. Think about this. I'll give you a little bit more hints. If you think about the value for I, over here, it's simply just going to be 0, 1, 2, and 3. Just that. However, these are not the indices we want to print out. No, it's not. Right? Because the first one I want to print out is not numbers at position 0. I want to print out numbers at position 3. Right? So now, That's why the body of the loop is going to say whatever value of I am given, I want to do a little bit massaging on the value of I. That's why this guy here is a little bit bigger than others. Okay? I will let you think about it for just about 10 seconds. Okay? Basically, what we want to do is, I'll give you more hints before I take any suggestion. The idea is you want to really see what's the relationship between the value for the counter I and the actual value of index you want to print out. Okay? Let's think about this. So now I want to say this. Let me put another column here. This is the value for I, and this is another column I would say to print index. Which index do I want to print? I know that the very first iteration I want to print out index 3. The second iteration I want to print out index 2. And then index 1, index 0. You can see the loop counter I is going to be 0, 1, 2, 3. But the index I want to print out is going to be 3, 2, 1, 0. So now, what's the relationship between I and the print index? That's the question. Let's try to be, well, anybody want to suggest something? Okay, if no, then let me give you something which is not perfect just yet. One way to think about just specifically for this example, I can simply say the following. I have a formula for you over here. I'll put it here, okay? A formula here, okay, in pink over here. I can say I is simply equal to the print index, okay, minus 3. Actually, no. Let me do it again. I think it'll be easier for you to see the following. How about this? You can say the following. You can say I plus the print index is simply equal to 3. What about that formula there? I'm saying the sum of the print index and the value for I is always 3 in this case, in this particular example. Agree? You can see 0 plus 3, 3. 1 plus 2, 3. 2 plus 1, 3. 3 plus 0, 3. Right? Let me move the term a little bit. So that means I, the print index over here, is simply equal to 3 minus I. Right? Do you agree? Okay? Again, 3 is simply 3 minus 0. 2 is simply 3 minus 1. 1 is 3 minus 2. 0 is 3 minus 3. Okay? Are we good so far? Okay? I'm just trying to show you how to figure out a pattern. Okay? So that means this particular formula might work just for this particular example. What I mean is, I can simply replace this part over here just by, because I say that print index should just be 3 minus I. I can just put 3 minus I for this particular example. Again, we are professional engineers. We should not be happy with any solution that's not general enough. What if I change the size of the array to be 100? Or to be anything that's other than 4? Then this formula wouldn't work. Okay? That's my hints to you. Can anybody try to think about on this direction? We're almost there. What I want to change is, I want to really change this formula here rather than print index is 3 minus I. I want to change it to something that's more general. That is simply just going to work regardless of the size of the array. Yeah, that's good. Okay, let's see exactly why. If you think about it, okay, for this particular value over here, you can see 3 minus I. Okay, if you got 3 minus I over here is simply the value for the loop counter. What about 3? 3 is not exactly just the size of the array. It's basically the maximum index of the array. What should that be? The length of the array minus 1. So that would be the length of the numbers, the length minus 1, minus I. Okay, so that's exactly how we derive the formula. Okay, so if you look at the answer, it's simply just going to be this. Okay, so these two solutions here, I would say maybe the first one is more intuitive to you, but for the second one, I think that for the sake of understanding more about loop counters, it's worth understanding that too. Okay? Are we good? Okay, I'll see you on Wednesday.